Hi, and thank you for watching this Fringe 2021 e-poster where I will present our preliminary assessment of ALOS 2 L-band SAR data for ice sheet monitoring. Our group is funded by NASA, and for this project we got a data grant from the Japanese Space Agency. We are producing geophysical information products for Antarctica, namely ice velocity and grounding line information. ALOS 2 Pulsar 2 is an L-band SAR mission with a repeat orbit of 14 days. Strip map data are available in limited amounts to principal investigators for scientific exploits. The challenge is that the mission adheres to a background observation scenario that does not include frequent interferometric observations in Antarctica. So we worked with JAXA to identify a number of target sites where, through a best effort basis, interferometric pairs are being collected. We decided on a number of sites distributed around the coast that were guided by recent research results showing loss over the last 40 years on these glaciers. And JAXA was kind enough to agree to try and collect interferometric pairs within their basic observation scenario. From our work on our reference ice velocity map shown here in the center of the image, we know reasonably well that L-band data is a huge benefit for ice velocity measurements, as ALOS pulsar data played a significant role in making this map possible. We also used data from other sensors, including Sentinel-1, Envisat, ERS, RADARSAT-1 and RADARSAT-2. But knowing that the data would work very well for ice velocity measurements, and the ALOS 2 velocity maps shown here are no exception, we focused on our other measurement, and that is grounding line, and therefore selected the target sites at the ice-ocean boundary. The grounding line is the boundary where ice detaches from the bed and starts to float in the ocean. It's of scientific significance. It's not a static line. It fluctuates with tide, for example, and it also indicates the health of a glacier in the long term. The grounding line can be measured using SAR interferometry by exploiting the vertical displacement that's tide related, and it is different for all four acquisitions needed to form a double difference interferogram. Our existing products are heavily based on C-band SAR data, although we have some ALOS pulsar data in the mix, as well as X-band from Cosmos SkyMed. And through the significant increase of data volume based on the Sentinel-1 mission, we also started looking at machine learning algorithms to delineate the grounding lines, which we delineated by hand in the past. The example double difference shown here is from Denman Glacier in East Antarctica, and this is our only double difference for this glacier. And we were quite pleased to see that the main trunk shows a grounding line signal, which we weren't able to see with Sentinel-1 data. Moving on to the next glacier, Totten Glacier in East Antarctica. Here we have multiple double differences, but only two show a significant fringe pattern that allows us to delineate the grounding line. That would be image A and D. There's one image that almost has no differential tide, that would be image C. Switching to West Antarctica, this image shows a quite more challenging scenario. We have a lot more decorrelation. And another example with zero differential tide. Our final glacier is Pineal Glacier, where we have no double difference signal that allows us to delineate the grounding line. Experience with Sentinel-1 shows us that there could be seasonally relevant interferograms that do show the grounding line. And with that, I'd like to thank you for your attention. please feel free to contact me by email.